It's even terrifying.
Yeah, did you see that? She went like this.
Oh, big stuff.
No. Like the bottom of my favorite pizza.
It should be on the top.
Did you realize she did the yellow ruler?
Huh?
The yellow ruler.
Okay.
I broke it in half.
Guys,
Really?
I'm recording, so I'd like to get started.
Oh, yeah.
Okay, and I would like us to get through all the notes today, so we can do what we did on Monday and Tuesday, where we did all the notes on Monday and you practiced on Tuesday.
All right. Well,
Okay, so 5-2 properties of exponents and radicals. So we're still using the exponents and the rational exponents and all that. We're just combining them for more stuff. So right here is just a reminder of our exponent rules. We've been using these exponent rules, haven't we? We've been doing things with exponents. It's just a reminder, so you remember. So, product power. When I multiply exponents, I do what with them?
Divide.
Add.
Oh.
Because multiplication is addition, yes?
Yeah, I can hear.
Multiplication is repeated addition. Why don't you move up here, Brad? Okay.
I want to be front row.
So then when I quotient means divide, yes? If I added when I multiplied, what am I going to do when I divide?
Multiply.
Subtract.
Darn it.
Because division is repeated subtraction. That's all it is. It's a quicker way to do subtraction. So I subtract those exponents. And here's examples over here. I guess I didn't show you. We're not just adding 2 and 1 anymore. We're doing 2/3 and 1/3. So those are fractions. So in order to add them, I have to have common denominators, yes? So that's something we'll have to remember. And so then I divide. It went up like this. So this is 3 to the 4th divided by 2 to the 4th. So it's 3 to the 4 minus 2. So it's 3 squared, which is 9. The one thing I do want to mention, guys, all of my bases are the same, correct? If my bases are not the same, I cannot do this math with them. Your bases have to be they have to be the same. So then when I have a power to a power, we were using this a lot over the last 2 days. If I have a to the m, all to the n, I multiply. So we had 7 to the 3rd times 2/3, so the 3's reduce, and it's 7 squared, which is
49.
49. We used that a lot yesterday and the day before, didn't we? So then the power product rule, we use this as well. If I have a times b with a power outside the whole parenthesis, I had to do what with that power? I had to distribute it in, didn't I? And that's when we added the x and y, we had to distribute it in. So if I have 16x to the 1/2, what does 1/2 mean? What root is that?
Half.
2?
Oh, yeah.
Second root, so it's the square root, right? So I'd have 16 to the 1/2, x to the 1/2, and the square root of 16 is 4. And I would ask that you put this back in, do 4 square root of x. We're not going to leave fractional exponents usually. Okay? Negative exponents, we had this come up in our notes also. If I have a negative exponent, it reciprocates it, doesn't it? What if I had 1 over a to the negative m? What would it equal? A to the m. I reciprocated. It works both ways. Okay, so here I have 5 to the negative 1/2, so I want the square root of 5, don't I? But the negative is going to put it into the denominator, and it's the negative on the exponent only, not on the whole problem. If it's on the whole problem, just the problem's negative. So it's 1 over 5 to the 1/2. So those are a review of the exponent rules, which most of them over the last couple days we've had to use, but we didn't explicitly review them. And now we're going to be adding just the rational exponents into it. So hopefully I don't have too much on one slide. If I do, I'll make new slides. I'll put copied onto another slide, okay? So I have 81 to the 5/6 times 81 to the negative 1/3. So that's multiplication. What do I do when I multiply?
You
Add, but it's negative, right? So this we
subtract.
extract.
So it'd be A to the third.
81 to the
Six.
5/6 minus 1/3,
Just 2/6.
which is 2/6. Good job. How'd you get 2/6?
Because there's
Common denominator, right?
2/3. Yeah.
So 5 minus 2 is what?
3.
3.
So it's 3/6,
So
which
it's
is a half.
81 to the 3/6,
Which is a half.
which is 81 to the half, which is
9.
9. How'd you get 9?
Because it's 9 is the square root, or 9 is the square root of 81.
Square root of 81.
Bada bing, bada boom.
So that's actually probably almost as complicated as it's gonna get.
That's it? That's what we've been doing the last 2 days.
I know. But we weren't actually like multiplying and stuff like that. Questions on that one, guys? I told you when I multiplied, I added, right?
Wait, so.
But why did I subtract
Well,
this?
wouldn't you multiply 81 times 81 then?
No, not your bases.
Wait,
No.
how's it?
Okay.
81 and a half.
81 to the half.
Yeah.
81 to the
How
half.
to get to the half?
That's because you have 3.
Oh, never. Okay.
Okay. So, we've been kind of doing this the last 2 days. We're just putting more stuff in it. But again, I
We've really
asked.
just gone into detail now.
Yeah. Could I have written this like a division problem? What's the negative exponent do? It puts it in the denominator, doesn't it?
Yeah.
So I could have written it like 81 to the 5/6 divided by 81 to the 1/3, because once I reciprocate it, it's not negative anymore. And when it's division, I subtract, correct? And then I subtract it. So it kind of works. I could have written that problem 2 different ways. Okay, so Dan or across?
Over.
Over? Okay, so this 1/2 has to go both. Where? Numerator and denominator. So it's going to go numerator and denominator. So it's going to be 3 to the 1/2, right? Over. Well, I'm going to have to take 2/5 times 1/2. So 2/5 times 1/2 is what?
2/10. It'll be 1/5.
1/5. 5's the one's reduced, yes? Okay, so I'm going to have 32 to the 1/5. Now, I do not have the same base in the numerator as I do the denominator, do I? No. So I cannot subtract those exponents. But I need to check if I can reduce the denominator. So I want the 5th root of 32. What do we know 32 is? 2 to the what power?
6. 5th.
It's 5th, isn't it?
Yeah.
Because it's 4 times 8. So I have 2 to the 5th to the 1/5. So what do I have in the denominator?
2.
2. And I don't know if the book lets you or not, but this is what root? What root? Squared. So if I wanted to put it in radical form, I just put it back in the root, right? Again, we couldn't do anything to 3 to the 1/2 and 32 to the 1/5 because our bases weren't the same, right? But if I could get like 30, maybe it was 27. Can I get 27 to a base 3?
Yes.
Yeah, then I could do more with it. So, now this one is.
Yes.
So this has to go here to the x, here to the y, and there to the x. Has to go everywhere. What's on this x right now?
1.
1. And when I have a power to a power, I multiply.
Yeah.
So I would have x to the
2/3.
2/3 and y to the,
6.
there's a 1 here.
5.
So the
No.
3's would reduce,
2.
so 2. If you didn't, you'd get 6 over 3, which would still be what? 2. And now I've got 1/2 times 2/3. Well, the 2's would reduce, yes?
Yes.
And it'd be x to the
1/3.
1/3. Now, I am not done because there are 2 x's there, yes? If there are any 2 of one thing, you are not done.
Simplify it.
So I have to simplify it further, and those x's are divided by each other, correct?
Yes.
So we need to do what with them? Add, subtract, multiply.
Multiply.
We're dividing,
Subtract.
subtract. Always subtract to the bigger number.
So it's an x to the 1/3 of y squared is what the answer would be.
Right, but yeah, just let me enunciate what I just said. Always subtract to the larger number, whether it's in the numerator or to the denominator, because you are going to be allowed to leave negative exponents. And if I subtract to the larger number, am I going to get a negative exponent?
No.
No. And what happens when I subtract a negative exponent?
Gets positive.
It becomes positive. Good job. So now I need to take this right here and do 2/3 minus 1/3.
Yeah.
So this is reduced. It's gone.
So it'd be x.
So it's going to be x to the
1/3.
1/3, y to the
Sorry.
second. Now, if it says radical form, what root is 1/3?
1, 3.
3. It's cube root, right?
Yeah.
So the y is out, isn't it? And it's the cube root of what? X. So you just have to read your instructions whether it says radical form or not. This would be very good to do so you can see, when I see this, I should see this. And when I have this, I should see this. My brain should just do it. Okay.
Where did Keelan go?
To the office. He doesn't follow.
What?
Okay, so where's this exponent, where's this 2/3 go to?
Into the parentheses.
Only to the parentheses, right? Nothing out here. This 2a to the 1/3 is, we've got to wait till we simplify everything else. Am I going too fast?
No.
Okay,
I'm writing down the.
Okay. I just want to make sure I'm not going too fast. Okay, so this 2/3 has to be distributed to the a and the b, right? So out here I have 2a to the 1/3. And that 1/3 is only on the a, correct? If there are parentheses, it's on both. So now I'm going to have what inside?
Parentheses, a to the 2/3
A to the 2/3
and a to the 1/3.
and
No.
b,
Or yeah, b
No.
1/3.
yep,
Oh, yeah.
because the 2's would reduce out.
Yeah.
So now I have 2 a's. Remember I said if you have 2 of anything, you're not done. So I need to combine them, don't I?
Multiply.
I multiply them, so what do I do the exponents?
2.
Add them. Do they have common bases?
Yeah.
Like they have common denominators, so I'm good there, I don't have to get it. So I have 1 plus 2 is
3.
3, so 3 over 3 is
one.
1. So it's 2ab to the 1/3. And what would radical form be?
It'd be square
3,
root and then 3 on the
2ab.
outside. So it'd be 3 and then square root 2ab.
Is the 2 and a in the root?
Or is it just 2a?
Or is it 2a?
It's 2a,
Square
the
root
cube
symbol
root,
A.
the cube root,
Radical whatever. Radical
the
sign.
cube root, say cube root. Cube root of b.
Cube.
Now, that 1/3 is only on the b because there's no parentheses. If there was parentheses, is it on all of it?
Yes.
Yes, so that's one of the things, the biggest mistake people make. They try to put that with everything, and it's only on what it's on.
You're gonna make that mistake, right?
No.
Watch me.
So why did A lose the 2/3?
Because I have
You can line
1/3 plus 2/3 is 3/3, which is 1.
it. Joe's over here like, what?
Okay, rewrite using radicals, rewrite the radicals using properties of exponents to reduce.
16x.
Okay, 16, what power is this? What power is cube root?
1/3.
1/3, we did this, we've done this the last 2 days. We need to get 16 lower.
2.
2 to the what?
4.
And 32 is 5.
Wait.
16 is 4 times 4. 2 squared is 4, so it's 2 to the 4th.
Yeah.
Okay, so I gave you some of these problems the last couple days. I said it's not always going to work out nice, correct? It's not always going to work out nice. Because this is going to go in here, isn't it?
Mm-hmm.
So when I do that, I'm going to have 2 to the what? 4/3?
Mm-hmm.
Yeah.
And x to the
5/3.
5/3. So we can pull some things out, can't we? Because I'm looking for groups of 3 and I have 4 and I have 5. I have 4 2s, don't I? So couldn't I bring one group of 2 out?
Yeah.
Yeah. So this is where I'm doing my mixed numbers. How many times does 3 go into 4?
Once.
Once. So I have 2 to the 1st and I still have 1 left over, don't I?
Mm-hmm.
Okay. How many
Oh, okay.
times does 3 go into 5?
1.
1. But I still have how many left over?
2.
2. So they're my mixed numbers. It's 1 and 1/3. It's 1 and 2/3. That's my mixed number. So the 2 and the x can come out of the radical, can't they? This 2, since it's a first power, if it's not rational, it can come out.
Yeah.
And the x can come out. Can this other 2 and other x come out?
No.
No. So it would be 2x, the cube root of 2 times x squared.
Yes.
Remember, degree is in the numerator, root is in the denominator. So, exactly like what we did over the last 2 days, but now we're going to have leftovers. We're going to have some stuff comes out and some stuff stays back in. So what power is the 4th root?
That's math. Pointless.
What power is the 4th root?
1/4.
1/4. And I can just put a to the 8th, b to the 5th, right?
Yep.
I need to break down 81. 9 and 9.
3 to the 4th.
3 to the 4th.
I'll get in there.
Okay, and if I have to sit to the side and break things down, I have to make factor trees and break things down, don't I? So now I distribute.
So it's 3a squared.
Yep, because 4 and 4 is 1. I'm just going to put a 1.
1/4 that.
A squared.
Right here, the root. Okay, so then a 4th of 8 is 2. And B is going to be 5/4.
Which is 1 and then 1/4.
It's 1 and
1/4.
1/4. So this B is going to stay in the radical, isn't it?
Yeah.
And everything else is going to come out. So I have
So it's
3
3b.
a squared.
Oh, well, I was gonna combine 3 and b together since they're the same.
Oh,
one.
okay. We should still keep with that alphabetical order.
Oh, well, okay, they're better. I mean,
But
it's still gonna be the same answer.
Right,
then, isn't
right,
it?
right. But we should just practice using.
Yeah, I'm not.
And then the 4th root.
Yes.
Of B.
Why is that so easy? Well, when is it gonna get hard? That's my question. 'Cause-
As long as you step through the process, it's not going to get hard. They're going to get more steps, but they're not going to be any hard. What's hard is when you guys look at a problem and go, "Oh, I should have the answer right now." You don't. You have to go
What
through the
all
steps.
this factoring? Okay.
Oh, well,
just
we'll be
can't
coming back to it. It's
do
not
it.
going away,
I
just so you
can't
know.
do it.
Not going away.
I
Okay.
feel like the
I got
15,000.
70 on my test. Shut your mouth.
I got 71.
Oh, really?
Yeah.
I got 70.
Okay, so let's hope this test boosts it up.
Wrong.
Okay, so we need to do a lot here,
Oh, that's depressing.
but what power am I going to be at?
3.
1/3?
This thing just sits here.
What are you doing?
Nothing. Ignore me. Just do your thing.
Okay. So, I have everything to the 1/3 power. Now, we know that 1/3 has to go to every single thing in there. No, I'm recording. If you don't need to be in here don't. So the 1/3 is gonna go to every single thing in here, isn't it? Yes? But I have an x in the numerator and the x in the denominator. Could I reduce before I distribute in the 1/3? Yeah. Why wouldn't I? So I have x to the 4th in the numerator and x to the 1st in the denominator. So 4 or 1, which one's bigger?
4.
4. So we're going to go up, right?
Mm-hmm.
And 4 minus 1 is
3.
3. So we're actually going to have x to the 3rd y squared over
125.
125. We got to do something with 125.
Factored out, which is
So it's
5
5
thirds.
quarters, right? 125 is 5 quarters. $1.25, 5 quarters.
yeah. That's 5 to the 4th.
25 to the 3rd.
Yeah, that's what I said. That's what I said to begin with.
Oh. We've done 125 several times, haven't we?
Yeah.
Yeah.
Okay, so now what are we doing that 1/3? It's going to
Distribute it
what?
out.
It's going to everything.
So x,
So x,
y,
X is 1.
x is 1, yep. Y to the
Third.
2/3.
2/3.
every day,
Where is it at?
right where you left it.
Really? Oh, nice.
Okay, over what?
Thanks, Brad.
over
5.
5.
Okay, so in radical form, what
What
root
is?
am I? I'm still the cube root, yes?
Yes.
So it's going to be x, the cube root of
Of y
y squared
Over 5.
over 5.
That's pretty darn easy.
Now, it would have made it harder if I would have distributed the 1/3 before I reduced the x's, wouldn't it? Because it would have been x to the 4/3 over x to the 1/3, and you'd have to. It would come out the same, but is it easier to think
It's
about
just
whole
more steps,
numbers?
is all it is. It's
Yeah.
no difference.
It's easier to think about whole numbers than not. Now, if I would have distributed and would have made them whole numbers, I would have distributed first. You just kind of got to think.
I don't do that very well.
I know some of you that's a struggle.
Do what?
Okay,
Think.
to think.
What?
So now I'm going to multiply. I just. I stop. I'm going to multiply and divide. I just simplified. Now I'm going to multiply and divide. So I'm combining what I did on the first slide with more stuff. So I both have 5th roots, yes?
So, yeah.
So I can multiply them together.
And 8 goes into 16.
So I have what root? I have the 5th root, yes? And I have 16 times 8.
Yeah.
Now, I'm not going to multiply out 16 times 8 because I want to see if I can bring stuff out of the radical,
You can.
all right? So 16 is what times what?
4 squared.
It's 4 squared,
Mm-hmm.
okay? So it's 4 squared, and 8 is 2
2 to the
cubed. So we probably need to make 4 into 2, right?
Yes.
So
So
4
it'd be
squared would
2
be 2 to the
fourths.
4th. Okay,
That's
so
two,
this
yeah,
is 2
2
to the 4th, yes. So I have 2 to the
Seventh.
7th,
Which is 2 to the 1st and 2 to
2
the
to the 1st,
2/5.
and 2 to the 2/5.
So it'd be 2 times radical.
5th root.
Fifth root. 2 squared.
See, it's easier like when you just like want to say it.
4 to the 1. 2 squared, same thing, right?
Right.
When you go
So,
to say
so
it,
if on my assignment I wrote it
figure
out
how
as
to
2
say it.
squared, would you still count it right then?
You need to finish, you need to say 4.
So then I have to put 4 down.
Yeah. Okay,
That sucks.
a little bit.
No, a lot of it.
Come on, who's this?
So,
Leave my water.
Tayton, I need you to focus. So, when I go through this, remember my roots have to be the same or my bases have to be same. You can't be mixing those things up, okay? We're going to go down. So what root am I?
3, 1/3.
1/3. The 3rd root, so 1/3. Now, can I reduce any of that?
No. The 3, I mean the 9.
I can do nothing with that. Like, that's the answer.
Oh, that's the answer?
Why is that the answer?
You can't do anything. Right.
You could reduce the 9.
Yeah.
No, you can't. Because I'm looking for cube root. And 9 is 3 squared.
Oh, that's fine with me. That's the
So
answer.
could I do anything with that?
No.
No. But we have a problem. When I distribute that in, we have a little bit of a problem here. Because we can't leave radicals in the denominator.
You made me circle out for no reason then?
No, I mean, there's nothing we can reduce, is what I'm trying to get. There's nothing we can reduce, but we do need to write it correctly. So what we have is the square root of 2n divided by the square root, is not square root, cube root, correct?
That was it. Yeah,
Cube root.
sounded wrong.
Of 9m. That's what we have, yes?
Yes.
We are not allowed to leave radicals in the denominator. We're not allowed to do that.
We turned to multiplication problem.
So we need to figure out, so this is really, I'm going to write it back as 3 squared m to the 1/3. Yes?
Yes.
So what I have here is 3 to the 2/3 times m to the 1/3. I need to get both of those to be 1.
Minor.
So, no, by multiplying. I need to make both of them 1 by multiplying. So, what do I need to add to 2/3 to get to the next, and I'm going to say the next whole number, guys, because if we had 5/3, what would be the next whole number? It would be 6.
Yes.
Okay? So, what do I need to add to 2/3 to get to 1?
1. 1/3.
1/3. So, I would multiply this by 3 to the 1/3, wouldn't I? Yes?
Sure.
Because what happens when I multiply exponents? I add them. What do I need to add to 1/3 to get to the next whole number?
3 and 1/3.
2/3. So if I need to do this in the denominator, I also have to do it where? In the numerator. So I have 2 to the 1/3, and I have n to the 1/3, right? Times 3 to the 1/3, n to the 2/3, m to the 2/3.
Easy.
Yes.
Because this right here over this, right here, isn't that just equal to 1? Because
Yeah.
it's 3 to the 1/3, m to the 2/3, 3 to the 1/3, m to the 2/3. Since they're exactly the like, they're just 1, just equals 1.
Wait, but wouldn't it be? No, never mind. Never mind.
Can I combine any of these?
Yes.
The 2 and the 1/3.
And, no.
Do I have
Because
any of the same
they're,
bases? Do I have any of the same bases? I have
Yeah.
2, n, 3, and m.
No, you,
2 and 1/3 and 3 and 1/3.
Yeah, but that's not the same base. 2 is 2 and 3 is 3.
so no.
Oh,
That's
no.
the answer.
Okay, I can't combine anything exponentially, correct?
Yeah.
So I essentially have here, and I'm going to have to rewrite that problem somewhere else, 2 times n times 3 times m, all to the 1/3, don't I?
Mhm.
Now can I multiply 2 and 3?
Mhm.
Yes? So I have 6 m n, the cube root. Yes?
Over
Just got
1.
distracted by a zipper.
Now, over here, we're still in the denominator here, yes? When I add 1/3 to 2/3, I get
1.
1, so that can come out of the radical. So I have 3 to the first.
And then.
And
3m.
M.
Is that the answer?
Why can't we just leave it like that? 'Cause there's a lot simpler.
Because we can't leave radicals in the denominator.
We can. What's a radical?
This symbol?
Oh, so you just take it out of that.
And so that's what we were doing, we were taking it out.
No.
Okay,
We can like skip that next one. Like the
no, I
next
think
one.
we need to add a slide. Write that problem down.
Which one?
The next two, write them down. Because I think we don't have enough room. I'm gonna have to add a slide. I don't wanna crowd it too much on there.
Alright.
Okay, you guys got both of them?
Yeah.
Okay. so I had the fifth root of 7/16, what?
X to the
X
third.
cubed.
X cubed. Okay, so there's nothing, the 7 and the 16x, I can't reduce anything there. If I could, I would do it first before I did anything else, okay? So this 1/5 is gonna go to the numerator and the denominator, correct?
Yeah.
Okay. So that would put a radical in the denominator where I can't leave it, can I? So I need to work on that denominator and figure out what else I need to make it whole numbers. So 16 needs to be down. 16 is 2 to the what?
4th, 8. No. Oh.
Because it's 4 times 4. Okay, so I still have 7 to the 1/5. And now I have 2 to the 4th times 1/5. So it's 4/5, correct? And I have x to the 3/5. So hopefully this is going to help you guys see it more pieced together than when it was the other one. So I need to multiply the numerator
1/5.
and denominator. So I need the next whole number would be 1, yes? So 2 to the what?
1/5
1/5
and X to the 2/5.
and x to the 2/5. And whatever I do to the denominator, I have to do to the
Numerator.
numerator. So in the denominator, I'm going to have 2 to the 5/5, which is what?
2/1.
To
Or
the
two-
first.
to the first.
And I'm going to have x to the 5/5, so it's just
2x.
x. Now, if I have the same bases up here, I can the same denominators in your exponents, I can multiply. Remember how before I pulled out the 1/5 or the 1/3 and I can multiply 2 and 3? So I can just do the same thing here. So I have 1/5 and I have 1/5, so that means I can multiply my bases. So 2 times 7 is 14.
14 to 2/5.
Well, no, because
No, you
the
don't have-
exponents just stay 1/5.
Okay.
Okay, and then I'm going to have x what?
To the 2/5.
Well, x squared, and it's all going to be what root?
Oh, to the 5th.
To the 5th. Because I have to put it back in radical form. So if the exponents are the same, you can multiply the bases. Because I could factor up here, I could factor out, I could make it 7 times 2 times x squared all to the 1/5, couldn't I? Could I factor out that 1/5? Yeah. Okay, so what was the other one?
Square, well, the 4, and then the square root.
It's 4 square root?
Yes.
No, like,
Like-
the square root.
It's the 4th root.
Yes, that
Yes.
thing.
Okay, we gotta
Four-
say it right.
Oh, I forgot how to.
I know, that's why I'm reminding you.
Alright,
The
and then
4th root,
27
27x squared.
over 3x.
No.
Over this is square
Square root of
square root of
3x.
3x.
on the,
No, beside it.
That's all.
oh, times.
Yeah, that's what we're trying to get at.
Oh, it's like that?
Yeah.
Yep, I think so.
That's what's
Yeah.
on there.
Oh, I put it over.
There.
Okay,
I'll do that, boy.
so we're multiplying, right?
What?
So we could just write it out.
Okay.
27 in parentheses
What-
27x squared 2d1/4.
Yes, okay. We cannot, other ones we've just multiplied the radical and what was under the radical, haven't we? But they have to be the same root. And I have the square root and the 4th root, so I don't have the same root, do I? So I'm gonna write it out like Brad just said. I'm gonna have 27. Oh, do we wanna do something with 27?
No, make it smaller.
No.
3.
3 to the what?
4.
Alright,
No,
3 to the 3rd.
yes. 3 to the 3rd, because 3 times 9 is 27, right? So 3 to the 3rd. I always do that because then if I can reduce, it's already done. Okay? X to the 2nd, all to the 1/4. And then we're gonna have 3x to the what? 1/2?
Yeah.
Because it's square root, I mean, there's nothing there, so it's the square root. So I need to do what with that 1/4 and 1/2? I need to distribute it in, don't I?
Yes. So 3 and 3/2.
3 and 3/4.
I meant that.
3 to the 3/4.
Yeah.
X to the
1/2.
1/2, because 2 over 4 is 1/2. Times 3 to the
1/2.
1/2. And x to the
1/2.
1/2. So now that I have the same bases, can I add exponents?
Yes.
Yes. If I have the same exponents, I can multiply bases. If I have the same bases, I can add exponents. I can multiply. So I have 3 to the 3/4 and 3 to the 1/2. So that would be 3 to the 3/4 plus 1/2. Yes?
So it'd be 3.
So I have to get common denominators, yes?
2. 4.
So 2/4. And so I get 3 to the 5/4.
Yes.
And then I get x to the what?
Is that 3 and 4 plus 2 to 4?
3/4 plus 2/4. What am I gonna have x to? What power?
Huh?
What's
Oh,
x?
it's 1/2.
1/2 plus 1/2 is
Oh, it's 2. Hold on, I'm confused.
a half plus a half.
1.
So it'd be x to the 1/2 plus 1/2, so it's 1. So I'm good. Now I need to finish. The x is out of the radical, yes?
Yeah.
What about the 3's? Can all of the 3's come out? Can none of the 3's come out? How many 3's?
All of them.
All of them?
I
3.
don't know.
Does 4 go into 5?
4 of them.
1.
4, so 5, it goes in there once, right? With what left over? 1. Remember, 4, it's that mixed number. Can't talk. So it's 1 and 1/4. So the 3 and the x can come out. And I still have the what? 4th root of 3. So are they going to take a few steps to do? Yes.
Sometimes.
But if you follow the rules, you should come out fine. Okay, adding and subtracting. I think this is the last. Okay,
Oh my god.
so we know from since we learned algebra that we can only add or subtract or combine things that are alike, correct? Yes?
Yeah.
So that goes for here too. We can't combine things unless they're alike. So we have to have the same radicand to be able to combine things. So what we have to first do, we have the square root of 20 minus the cube root of 16 plus the cube root of 250 minus 5, or square root of 5. So I need to look at what I can combine. Well, first of all, the only thing I could possibly combine are these two and these two, because I have square roots and cube roots. I can't add different roots to each other. But the radicands have to be the same. So I need to simplify them. Is the square root of 5 simplified?
No.
Yes.
It's not.
It is. There's no perfect squares in 5, are there? Okay, what about
2 and 3.
4 and 5.
Uh-huh.
4 and 5? So what's the square root of 4?
2.
2. So this is 2 square root of 5, isn't it?
Mm-hmm.
And then minus the square root of 5. So then we got here, I got cube root of 16. 16 is 2 to the 4th, yes?
Yes.
So can I bring all my 2's out?
Yes.
It's cube root.
No. You can bring 2.
I can bring, how many?
2. 1.
1. And 1's left in there.
Yes.
Okay, 250. Well, let's think 25. 25 times 10, right? So 25 times 10, so how many 5s are there? 3?
Mhm.
And times 2? So I have 5 cubed times 2. It's a cube. Times 2, all to the 1/3. So I can bring out 1 5, yes? And it's the cube root of what still? 2. 2. Where'd you get 3?
I'm assuming verb, but it's the same.
Okay. Okay. So,
I thought you were talking something else.
okay. We've reduced everything, yes?
Mm-hmm.
So we can look at the square roots. So their square roots, they match. Do the radicans match under the square roots?
Yes.
Yes. So there's a 1 here, isn't there?
Mm-hmm.
Like there's always a 1 there, right? This is just like x's, guys. Just like x's. If I said it was 2x minus x, what would you tell me?
It's X.
It's x. So it's just 1 square root of 5.
So then it would be
So now I have cube root, they match, yes?
3 cube root of 2.
So plus 3 cube roots of 2.
Is that the answer?
Yep.
Why is that so easy?
What? It's not easy.
So the first thing you had to do was simplify them all down so you could see what matches up. If it doesn't match up, if you simplify them all down and you don't have any radicans that are the same, you can't combine them. You're done. If you don't have any roots are the same, you can't combine them. You're done. The roots have to be the same and the radicans have to be able to the same to add or subtract. So now, which one do you want to do? The what?
That one. That one.
This one? Okay.
No, that one.
So
It really doesn't matter.
it doesn't matter. Okay, so we need to get 2,000 broken down, don't we?
50.
50? 50 goes into 2,040 times, right?
Yeah.
Okay, so at 50 times 40. So
That's 2,000.
this is, yep. So 50 is 25 times 2. And 40 is 5 times 8. So 25 times 2 and 5 times 8. And the reason why I did 5 and 8 instead of 4 and 10 is because I have some 5s and 25 already, don't I?
Yeah. 5.
Yeah?
5.
So what I have here then is how many 5s?
3.
3. So 5 cubed. And then I'm going to take everything else to 2, right?
Yeah. it'd be
How many
2,
2s are in 8?
2.
4.
3?
Cubed. So it'd be 2 to the 4th.
Oh yes, 2 to the 4th. So you guys are going for the answer. 2 to the 4th, all to what power?
Oh, we never do a 4th.
The 1/3, right?
Yeah.
Okay. This is done. Yes?
Yeah.
2. So plus the square root of 2. And it doesn't have the same root of any of the rest. So it would have to go anyway. And actually, I'm just going to erase it. And I'm going to put it off to the end. Because I can't do anything with it. It's not common with anything else. So it's just going to be at the end product anyway. Okay, so I need to break down 128.
9.
9 and what?
It'd be 4.
9 does not go into that.
That does.
No, it does not.
How did you get 9?
I don't know.
9 doesn't, because if you add them up, you don't get anything that is divisible by 9.
12.
So,
How
Well,
about
it's going to be
4?
5 and 2 in the end.
How about 4?
Let's be an odd and even number.
40.
How about 4?
Alright.
How do I know 4 goes into that? Because 4 goes into 28, correct?
And add into 8.
So 4 and then 32.
32.
So we can put it in a bunch of 2's, can't we?
Mm-hmm.
So this is 32 is 2 to the 5th and 2 squared. So we have
2 to the 7th.
2 to the 7th
1/3.
to the 1/3. So now we need to see what we can bring out of these. So I need to distribute my 1/3 in here.
5 and.
So it's going to be 5.
It'd just be 5.
Does 3 go into 4?
And then 1 time.
1 time. So I can bring 1, 2 out. And then I'm going to have 1 left in here. Okay. How many times is 3 going to 7?
Twice.
Twice. So I can bring 2 out and 1 left in there. And then plus square root of 2. Right? So what is 5 times 2?
10.
10. So this is 10. And what is 2 squared?
2, 4.
4. So can I combine these two things?
Yes.
Yes. So 10 minus 4 is
6.
6. So I get 6 cube root of 2 plus the square root of 2. And I do not know why that was so hard for my mouth to say that. I wanted to say square root. You guys want to try the next one on your own? Okay, they're all square roots, yes?
Mm-hmm.
So if they all have the same radicand, I can combine them, correct?
Yeah.
Okay, so 20 should be easy.
5 4.
5 and 4, so the square root of 4 is 2. So
Why
it's
can't it
2
be 20 and 1?
because you're looking for perfect squares to simplify it.
Because then you would have gone 5 4 again.
Okay, 600,
30.
30 and what?
60 and 10.
60 and 10. I could do 25 also, right?
30 and 30.
25.
No, 30 and 30 is.
30 and 20.
Okay, so 20 and 30. This is 4
Frick, yeah.
times 5, yes? This is 5 times 6, which is 2 times 3.
Mm-hmm.
So what can I bring out?
2,
5 squared.
5,
What's the square root of 4?
2.
2,
square root of 2.
and then
2
5.
squared.
And that's just left over, isn't it?
Yeah.
125 is 5 what?
5 to the third.
5 to the third. So this is 5 to the third, so I can bring out one of them.
Mm-hmm.
Now, I all have the same root, yes?
You,
But do I have any of the same radicand?
no.
No. So I cannot combine anything. My answer is going to be 5 square root of 5 minus 10 square root of 6 minus 5 square root of 3.
Where did you get 10 at?
2 times 5.
It's gonna be a negative.
I thought it was 25.
Oh, never mind.
Okay, so they were all square roots, but when I simplified them, did they have any same radicands? No. And that is the last example.
Well,
that's great.
right now, that's
Well,